Hello and welcome to our lesson on working with surds. In this lesson, we will build on our existing knowledge of powers and roots by introducing the concept of surds. Here's what we'll cover. We'll start by defining what surds are and why they are important. We'll then explore how to simplify surds and how to perform basic operations with them. We'll then apply this new knowledge to various examples and problem-solving scenarios to reinforce our understanding. In our previous lessons, we've established a strong understanding of powers. We can grasp the meaning of exponents and how to perform calculations involving powers. We also learnt about roots. We understand square roots, cube roots, and higher order roots, and how to work with them in equations and expressions. With this foundation, we are ready to learn about surds, which are essential for dealing with irrational numbers, which cannot be expressed as a simple fraction. Firstly, what is a surd? A surd is an irrational number that can't be simplified to remove the square root or cube root. Some examples of surds include root 2, root 3, and the cube root of 5. The key property of a surd is that it cannot be simplified into a rational number. For example, root 4 is not a surd because it simplifies to 2, which is a rational number. On the other hand, root 2 is a surd because it cannot be simplified into a rational number. So how do we go about simplifying surds? Here's a step-by-step process. Firstly, identify the factors of the number inside the surd. For example, to simplify root 50, identify the factors of 50, which are 25 and 2. We can therefore write root 50 as the root of 25 times 2. Then look for perfect squares or cubes among the factors. In this case, 25 is a perfect square, meaning its square root is equal to 5. Now that we know root 25 is equal to 5, we can simplify our surd from root 25 times 2 to 5 root 2. Therefore, we have found that the simplified form of root 50 is 5 root 2. Now let's move on to understanding expansion. When expanding brackets that include surds, use the distributive property, also known as the FOIL method, which stands for first, outside, inside, last. Let's try this with an example. Expand this expression. To do this, we follow these steps. Step 1 is to distribute each term in the first bracket to every term in the second bracket. See the expansion on screen in the order of first, outside, inside, and last. Step 2 is to simplify the resulting terms by combining like terms and simplifying surds. The result of this is 2 minus root, 2 plus 3 root, 2 minus 3. And finally, step 3 is to combine like terms. Here we combine the rational numbers 2 and minus 3 and the surds minus root 2 and 3 root 2. The result of this is minus 1 plus 2 root 2. Now let's look at how to solve equations involving surds. Let's solve the square root of 2x plus 3. Minus 5 equals 0. Step 1 is to isolate the surd on one side of the equation. To do this, we can add 5 to both sides of the equation. Step 2 is to square both sides of the equation to eliminate the SSURD. So in our case, we get 2x plus 3 equals 25. Step 3 is to solve the resulting equation. We can subtract 3 from both sides of the equation to get 2x equals 22. Then we can divide both sides of the equation by 2 to get x equals 11. Our final step is to check for extraneous solutions by substituting back into the original equation. So we substitute x equals 11 back into the original equation and find that the solution x equals 11 is correct. Great. Now let's dive into some more examples to consolidate what we've learned. In our first example, we'll try adding surds. Let's try 2 root 3 plus 4 root 3. In this case, both surds involve root 3. Therefore, we can easily combine the coefficients. We do this by simple addition, since 2 plus 4 equals 6. The result is 6 root 3. Now let's try multiplying surds. This can be a bit more complex. Let's work through. Root 2 multiplied by root 8. Firstly, we multiply the numbers under the root. This gives us root 2 multiplied by 8. Then we can simplify the expression under the root. So we get root 16. Finally, we simplify the square root. The square root of 16 is 4, as 16 is a perfect square. Finally, let's look at a more complex example of simplifying surds. Take the expression root 18 plus root 32, and simplify it. First, we need to simplify each surd individually. Let's start by taking root 18. We can write this as root 9 times 2. We can then simplify this to root 9 times root 2. Since root 9 is equal to 3, then we can write this as 3 root 2. Secondly, we can simplify root 32. First, write this as root 16 times 2. We can then write this as root 16 times root 2. Since root 16 is equal to 4, we therefore get 4 root 2. Now that we have simplified both parts of the initial expression, we can combine the like terms. 3 root 2 plus 4 root 2 is equal to 7 root 2, since root 2 is involved in both parts. Thus, root 18 plus root 32 simplifies to 7 root 2. In today's lesson, we explored the concept of surds, a crucial topic within powers and roots in mathematics. We started by defining surds as irrational numbers that cannot be simplified to remove the root, such as root 2, root 3, and the cube root of 5. Next, we delved into the process of simplifying surds by identifying factors and perfect squares within them, enhancing our ability to handle these expressions efficiently. We then moved on to expanding brackets involving surds using the distributive property to manage expressions like root 2 plus 3, root 2 minus 1. Finally, we tackled solving equations that involve surds. By isolating the surd, squaring both sides of the equation, and solving the resultant linear equation, we found solutions and verified their correctness. By mastering these techniques, we can handle irrational numbers with greater confidence, enhancing our problem-solving skills in both academic and real-world contexts. Watch the rest of the GCSE Maths course at Sophos Education.